to the next module on liquid dosage form. So, in continuation to the previous module in which we have covered syrup, elixir, their formulation, and in this module we will be covering suspension. By the end of this module, you will be able to understand what are suspensions, what are advantages, disadvantages of suspension, and what are the different theories of suspension, flocculated, deflocculated suspension, and formulation and evaluation of pharmaceutical suspension. This is going to be our lesson plan: introduction of suspension, merits and demerits, classification, and the ideal properties of suspension, theories and formulation aspect of suspension, stability, as well as packaging and storage. So, pharmaceutical suspension, two-phase system. A pharmaceutical suspension is a coarse dispersion in which insoluble solid particles are dispersed in liquid media, and the particles have diameter for the most part greater than 0.1 micrometer. So, please remember, this is biphasic dosage form, both suspension as well as emulsion. So, there are always two phases. So, let us see what are the advantages of suspension. We can improve the chemical stability of certain drug. For example, procaine penicillin G drug. So, this drug exhibits higher rate of bioavailability as compared to the other dosage form. So, bioavailability, it is always in the following order, like solution has the maximum bioavailability, then suspension, then capsule, then compressed tablet, and then coated tablet. And the control, duration and onset of action is another advantage of suspension. And test masking, of course, we can mask the bitter taste of certain drugs. For example, chloramphenicol palmitate, it has got the bitter taste, so it can be formulated in the form of a suspension. So, let us see what are the disadvantages. Uniform and accurate dose cannot be achieved unless suspensions are packed in a unit dosage form. Stability problem, it has physical stability problem. There are certain precautions need to be taken for the storage of suspension, and sedimentation and caking may create problem. So, they are bulky preparations. So, therefore, sufficient care must be taken during handling and transport, and it is difficult to formulate. Let us see classification. So, based on routes of administration, we can classify them as an oral suspension, externally applied suspension, and parenteral suspension. And based on the size of solid particles which are dispersed, colloidal suspension having particles less than 1 micrometer, and coarse dispersion having particle size more than 1 micrometer in size. And based on the electrokinetic nature of solid particles, we classify them as an flocculated and deflocculated suspension. And based on the proportion of solid particles, dilute suspension and concentrated suspensions. So, it is all about classification of suspension. Now, let us see why to go for suspension. What are the criteria for selection of drug to be formulated in the form of suspension? So, the very first, chemically unstable drug can be formulated, and we can ensure the stability of an active pharmaceutical ingredient in the liquid form. So, this is particularly advantageous for the infants, children and elderly patients in preparing a palatable liquid dosage form. Drugs that have very low solubility are usually formulated in the form of suspension. Insoluble form of drug may prolong the action of a drug by preventing rapid degradation of drug in the presence of water, and of course, bitter taste of the drug can be masked if it is formulated in the form of suspension. Now, let us see what are the ideal properties of a suspension. It should be therapeutically active, and it should be stable, physical stability, as well as it should have chemical stability. The consistency should be uniform after shaking, and it should settle down slowly and should be redispersible upon gentle container shaking, and it should not form hard cake, and the particle size of the suspended particles should remain fairly constant throughout the long period of undisturbed standing, and it should be readily pourable and evenly from its container. So, these are the ideal property of a suspension. Let us see theories of suspension and understanding sedimentation. Sedimentation is the process of settling down of the particles which are suspended in the liquid phase. So, the factors affecting the rate of sedimentation can be explained by the Stokes equation. It states V is equal to 2r square sigma minus rho multiplied by g divided by 9 eta, where V is the velocity of sedimentation of a spherical particle of radius r, and the density sigma, and in a liquid of density, that is rho, and the viscosity eta, and g stands for the acceleration due to gravity. So, the equation of the Stokes law, it says that the larger particle exhibit greater velocity of sedimentation, and the velocity of sedimentation is inversely proportional to the viscosity of the dispersion medium. So, this is about sedimentation and the concept of sedimentation. Next, we will see interfacial phenomena. The interfacial phenomena explains that the smaller particle size having larger surface area, it is associated with the surface free energy and making the suspension thermodynamically unstable, and the particle possesses higher free energy. They leads to grouping together to reduce the surface free energy, and it leads to the formation of floccules. So, these floccules are held together among themselves by weak van der Waals forces. So, the system tend to reduce the surface free energy, which may be accomplished by reduction of interfacial tension, and that is achieved by the use of surfactant. So, it is about the interfacial phenomena of suspension. Now, let us see zeta potential. Zeta potential, it is an indication of the stability of a ideal suspension. It indicates the degree of electrostatic repulsion. For molecules and particles that are small enough, a high zeta potential will confer stability. That is, the solution of dispersion will resist the aggregation. When the zeta potential is small, the attractive forces may exceed this repulsion, and the dispersion may break the flocculates. So, high zeta potential electrically stabilizes the suspension, while the low zeta potential tend to coagulate or flocculate the suspension. The theory of suspension can be explained by DLVO theory, and this DLVO theory is named by the different 4 scientists. So, dear learners, get back to the discussion forum with the name of different scientists who gave this theory, that is DLVO theory. So, what it says? It says that the stability of a suspension depends on the van der Waals attractive and electrical double layer repulsive forces that exist between the particles as they approach each other due to the Brownian motion they are undergoing. Of course, van der Waals forces depends on the chemical nature and size of the particle, and the electrostatic repulsive forces depend on density, surface charge, and the thickness of double layer. And when we talk about Brownian moment, it prevents the sedimentation by keeping the dispersed material in random motion. So, Brownian moments depends on the density of the phase and the density of the viscosity of the dispersed medium. And when it occurs, the Brownian moment occurs if the particle size is about 2 to 5 micrometer in size, and when the density of the particle and the viscosity of medium are favorable. So, let us summarize what all we have studied so far in this module. We discussed about introduction of suspension, what are the ideal properties, what are the advantages, disadvantages of suspension, theories of suspension, concept of sedimentation, interfacial phenomena, setup potential, DLVO theory explaining the Brownian moment. So, next we will see the different types of suspension, flocculated and deflocculated. These are two types of suspension. Now, let us see flocculated suspension. Flocculated suspension, in this type of suspension, the solid particles of dispersed phase aggregate together, leading to form a network like structure of solid particles in the dispersion media. So, the aggregate form no hard cake. So, this aggregation settle down rapidly due to their size, as the rate of sedimentation is high and the sediment which is formed is loose in consistency and it is easily redispersible. So, let us see the properties of flocculated suspension. Loose aggregate. So, flocculated suspension, they form loose aggregate and the rate of sedimentation is high and the rapidly they form sediment. The sediment is loosely packed, particles are not bonded tightly to each other. The sediment is easily dispersed by a small amount of agitation, like the mechanical energy which is needed to redisperse the suspension is less, and it exhibit plastic and pseudoplastic behavior. The pressure distribution in the flocculated type suspension system is uniform at all the places, and the viscosity is nearly same at different depth level, and the purpose of uniform dose distribution is fulfilled by the flocculated suspension. Deflocculated system. So, in this system, the solid particle exists as a separate entity in the dispersion media. The sediment form hard cake and the flocculated system forms loose cake. So, the solid drug particles, they settle down slowly as the rate of sedimentation is low, as sediments which are formed in deflocculated system. So, because there is a hard cake formation, so there will be difficulty in the redispersion. Let us see the properties of deflocculated system. So, particle size is less, the rate of settling is low, the sediment after some period of time becomes very closely packed and a non-dispersible cake is formed which should not be formed. But in deflocculated system, so there is a formation of cake which is non-dispersible or it is difficult to redisperse. So, the supernatant liquid is cloudy even though the majority of particles have been settled. So, there is no clear cut boundary between the sediment and the supernatant liquid. So, this is what about the properties of deflocculated suspension. Now, let us move to the formulation of suspension. Active pharmaceutical ingredient, that will be the main component, and then vehicle, the suspending media, wetting agent, the compound allowing control of stability and sedimentation. So, here we use flocculating agent and suspending agent, pH regulators and other additives like flavor, color and different other different types of preservatives which are used. Drug, that is the active pharmaceutical ingredient with the defined size distribution of the powder and with the defined chemical and the physical stability is used. Vehicle for suspension, we have already covered the different types of vehicle in our liquid oral module. So, the distilled water or deionized water, non-aqueous vehicle and the structured vehicle. Structured vehicle which is used as a vehicle for suspension formulations. These structured vehicles are pseudoplastic and plastic in nature, and it is desirable that the thixotropy is associated with the structured vehicle. So, let us see wetting agent. So, these are the agents, they ensure the adequate wetting. So, the interfacial tension between the solid and the liquid, it must be reduced. So, the absorbed air is displaced from the solid surface by the liquid. So, surface active agent, hydrophilic colloids and different types of solvents may be used as a wetting agent. Surface active agent that reduces the surface tension as I mentioned, and surfactant possessing an HLV value between 7 and 9 would be suitable to be used as a wetting agent. Surfactant like polysorbate, sorbition ester, sodium lauryl sulphate, sodium dioctyl sulfosuccinate. These are few example of the surfactants which are used. Let us see hydrocolloids. So, what are hydrocolloids? These are the material, they include acacia, bentonite, tragacanth, alginate, xanthan gum and cellulose derivative, and it will behave as a protective colloid by coating the solid hydrophobic particle with a multimolecular layer. So, the solvents materials such as alcohol, glycerol, glycose which are water miscible and that will reduce the liquid air interfacial tension may be used as a wetting agents. Flocculating agents, to impart the correct degree of flocculation, flocculating agents are added and they may be electrolyte, surfactant and the different types of polymers. The most widely used electrolytes include the sodium salt of acetate, phosphates and citrate, and the concentration is chosen will be that which produces the desired degree of flocculation in the suspension. Surfactants as a flocculating agent, ionic and non-ionic surfactant both can be used. So, dear learners, please go through from the examples of ionic and non-ionic surfactants and get back to us in discussion forum. Then the polymeric flocculating agents like starch, alginate, cellulose derivative, tragacanth, carbomers and silicates, these are the examples of polymer that can be used to control the flocculation. Structured vehicle, I mentioned structured vehicle earlier also. So, the structured vehicles are the vehicle containing thixotropic compound polymer like acacia which are pseudoplastic or plastic in nature. So, thixotropic compound or the polymer to form a three-dimensional gel network like structure which entrap the particles so that ideally no settling occurs. So, this is the role of structured vehicle. So, it can also be used as a media for the preparation of suspension. So, dear learners, we have covered flocculated and deflocculated suspension, their properties, formulation aspect of suspension, dealing with the different type of wetting agents, flocculating agent, structured vehicles, which are used in the formulation. So, the next we will see the suspending agents. So, this is an important aspect in the development of suspension, that suspending agent must be added, and it increases the viscosity of the vehicle, thereby slowing down the sedimentation. And the most commonly used surface active agents, we can classify them as a polysaccharides. You can take example of different polysaccharides like acacia, tragacanth, alginate, starch, xanthangum, and hydrated silicates is in another category of suspending agent, and the example of hydrated silicates are bentonite, magnesium, aluminum silicates, and hectorite. Carbomers is in another category of suspending agent. So, carboxymethyl cellulose you can use, colloidal silicon dioxide, water soluble celluloses like methyl cellulose, hydroxyethyl cellulose, and microcrystalline cellulose. So, these are few examples of suspending agents. So, based on the requirement and based on the suitability of an ideal suspending agent, we can use them in the development of suspension. Next, coloring agent, preservative, and pH modifier or the pH controlling substances we can say. So, coloring agent they are added to impart the desired color to the suspension and to improve the elegancy. So, color can be correlated with the flavor which is used, and the preservative they are added to prevent microbial growth. So, parabens and benzoate can be used as a preservative in the suspension, and pH can be monitored by using the different buffer system. Method of preparation, suspension can be formulated. The very first step, the wetting and dispersion of active ingredient. So, first of all what we have to do is we have to get the desired particle size by milling and then add it to the low viscosity portion of the product. So, this allows for most efficient mixing and homogenization, and then wetting agent is added to it. Then in the next step, stabilization of dispersed solids. So, addition of electrolyte is done to produce the charge around the each particle, and it allows for the electrical repulsion to prohibit the particle interaction. In the third step, we do preparation of vehicle. So, the polymer is added and allow this mixture to stand for up to 24 hours to ensure the complete hydration of the polymer. When the hydration of polymer is completed, the next step is the addition and the dispersion of vehicle. The dispersion of active ingredient is added to the vehicle with low intensity mixing. The mixture is then homogenized to ensure the uniform dispersion of the ingredient, and the next step is the addition of the remaining ingredient and the final mixing. So, it was about the method of preparation of suspension. Methods of evaluation of suspension. So, suspension is evaluated for the physical appearance, color, odor and taste, the particle size determination, the redispersibility, we have to check the redispersibility and the degree of flocculation, zeta potential measurement, sedimentation volume and the rheological measurement. So, we are going to measure viscosity in rheological measurement, pH and the crystal growth. Let us see how to determine the sedimentation volume. The sedimentation volume of a suspension, it is expressed by the ratio of the equilibrium volume of the sediment Vu to the total volume Vo of the suspension. So, F is equal to Vu divided by Vo, the value of F which provides a qualitative knowledge about the physical stability of the suspension. Degree of flocculation, we need to know the degree of flocculation when we are going to prepare a stable suspension dosage form. So, the degree of flocculation, it is the ratio of the sedimentation volume of flocculated suspension denoted by F to the sedimentation volume of deflocculated suspension denoted by Fd. So, beta is equal to Vu divided by Vo flocculated one divided by Vu divided by Vo of deflocculated. Redispersibility. Redispersibility in a suspension can be determined by the number of upside down inversions of the suspension contained in a measure. The smaller the number, the easier would be the redispersibility of a sediment. A number greater than 15 inversion indicated caking. Rheological properties, we are going to measure viscosity. So, different types of viscometers can be used, for example, cone and plate viscometer, cup and bob viscometer, falling sphere viscometer, Ostwald viscometer. These are different types of viscometers which are used to measure the viscosity or the rheological property of a suspension. Zeta potential measurement and particle size. The determination of electrophoretic property like zeta potential, it is useful for assessing the flocculation since the electrical charge on the particle influences the rate of flocculation. So, it can be measured by using zeta meter, and the particle size in the suspension can be measured by using the different microscopic methods. So, dear learners, get back to us with the different types of microscopic methods which are used to determine the particle size in the suspension. Let us see stability of suspension. So, small particle size, and the particle size should be small for an ideal stable suspension, and viscosity should be more for stable preparation. Temperature, so fluctuation in the temperature should not be there. So, it leads to the cracking of the system. What is the label requirement, the special label requirement for the suspension? They are having the small aggregates and the particles disperse in a liquid phase. So, it should be labeled with shake well before use. So, this is the label which must be there on suspension. Let us see packaging and storage. Packaging, it should be packed in a wide mouth container having adequate air space and should be stored in air tight container protected from freezing, and the temperature fluctuation, as I mentioned, should not be there in suspension preparation. So, dear learners, what all we have covered in this module is all about suspension, different types of suspension, classification, formulation, different theories of suspension, method of preparation, evaluation. So, please go through from the suggested further reading and do take part in the discussion forum if you have any query regarding the content of this module.